Hello, everyone. My name is Ajahn Nathakan Soikapkeo or Ajahn Nan. I'm going to introduce you to the new type of material, a composite material. Okay, but before, I hope you remember from the previous lecture about metals that they are good conductors of electron and heat, strong, deformable, non-transparent, and sometimes they occur rust. Okay, so they're susceptible to chemical degradation and high density or heavy. Okay, next, ceramic and glass. So this, in the opposite to metal, they are insulator of electron and heat, hard, brittle, not deformable. Okay, some of them transparent, good corrosion resistant, this material, and also good heat resistant. And the last type of material, polymers. Also, they are insulator of electron and heat, but very flexible, deformable, but low strength. Okay, some of them transparent, also good corrosion resistant, but low resistant to heat and low density or lightweight. So you can see good and bad of each type of material. Okay, but what if we want good properties of each material? How? The answer is to combine them into a composite material, which I am going to talk about. And composite material is combined material, okay, from metal, that could be ferrous metals and alloy, or non-ferrous metal, or from ceramic, glasses, graphite, diamond, or from polymer like thermoplastic, thermoset, and elastomer, or rubbers. So composite materials can be reinforced plastic, okay, and then metal matrix composite, ceramic matrix composite, sandwich structure, concrete. This is just examples, okay? Right, let's know more about composite material. Actually, composite material defined as the material that combine of two or more materials together that results in better properties than those of the individual component used alone in particular application. Okay, and the example here could be carbon fiber reinforced composite wheel here on the left-hand side, or this wind turbine in the middle of the sea, huge and tall. They are synthetic composites. And if we picture them, the composite, if we zoom in, we can see a close-up of what composite might look like. It could be like these blue fibers. They stay in or dispersed in a matrix, the yellow matrix, continuous matrix. But these two phases, fiber and matrix, they are different. Okay, they are separated by a distinct interface. So we can see, okay, which phase is fiber, which phase is matrix. But they stay together, combined. And the main advantages of composite material said that they are normally high strength, okay, high stiffness, but low density. So all good, right? And the example, excellent example of composite material. It is from nature, actually. Perfect example, like our bone. The bone that support our whole body. Strong, but light also. If we look at the whole bone on the right-hand side, and we zoom in to the secondary osteons in 100 micron or micrometer level, we can see it's already looking like composite, right? Okay, with this Hauerschend lamellae, this, if we zoom in, we will see that they are fiber arrays around 5 micrometer supported inside. And this fiber array, if we zoom in again, we can see that this fiber came from mineralized collagen fibrils. The scale is around 1 micrometer. And then if we zoom in further, we can see that this mineralized collagen fibril, actually they are made up of collagen molecules in 300 nanometer scale. And this reinforced making them stronger by hydroxyapatite nanocrystal that are around 10 nanometers. Yes, this is the whole structure, level by level, of our bone. This natural composite material are fascinating. They are actually natural nano composite, or the composite level down to nanoscale. That's why this bone can support our whole body, but still light. Can do a very good job, right? The second example is this nacre, or mother of pearl. Actually, yeah, it is a seashell. And maybe some of us experience it already. It's very tough, strong, and light. Okay, when we throw it away, like we are maybe, okay, going to the sea, the beach, and we see this seashell, and then we try to break it. It's not possible. They are so tough and strong, okay, and not heavy at all. Then if we zoom down into this structure, again, we can see that they are, again, composite material, okay? But now the composite structure changed into this bricks and bricks lay up together. Again, in nanometer level. This, we can see these nano plates stacked together, layer by layer. And this is why making this seashell so tough to break, very difficult to break, because of this nano brick by brick composite structure. Okay. And of course, we are human, we try to copy the best of nature also. On the right-hand side, it's natural nacre composite, right? On the left-hand side is our synthetic human-made hybrid aluminum oxide and aluminum silicate composite. You can see the difference, left on right. For human-made, man-made, on the left, we can do the job. Yeah, we can do good job, but not as good as nature does. Okay, but we can copy or mimic in some good level of composite, of natural composite, and get better and better, okay, properties of composite material. Okay, from nature, let's see our synthetic man-made composite material, how it's normally look like. They normally look like this, left and right, fiber or short fiber and long fiber, okay? Or we can call it filler. They disperse in matrix or continuous phase. And this continuous phase, they have greater quantity, okay? And then this fiber of filler, we put it in there to make this whole composite stronger and stiffer, right? But we can identify, right, the separate phase between fiber and matrix. So they have a distinct interface that we can see of two materials or more combined together in a composite material. And the fibers of filler may be short or long fiber. When short, we call it discontinuous fiber. When it's long, we call it continuous fiber. The main type of synthetic fiber that used in a composite material, there are three main types. First one, glass fiber. Second one, in the middle, carbon fiber. And the third one, ceramic fiber, the yellow one, or Kevlar. Okay, these are three main types of fiber that used in composite industry. If this fiber they make in smaller diameter, they can be greater flexibility and then easier to fabricate them into fabric and then use them in composite materials. All right. Okay, and the last 2 decades, let's say, because of the environment awareness, or okay, we see the impact that we do to our environment, right? Okay, so research and development has been focused more and more on this natural fiber also, green fiber. And this is renewable fiber, right? For example, this wood, jute, flax, hemp, sisal, all this natural fiber becoming focus to use more and more in new application to replace the other conventional fiber, okay? Because it's better to the environment. And you can see the example of natural fiber composite that already in the market and used in automotive or car application. Like in this slide, the photo I show here, it's already used in cars, natural fiber composite. How to make this composite material? Are we talking about composite manufacturing? How to, like this wind turbine, very tall in the middle of the sea. So it's huge, right? So this huge turbine blade, you can see. So we have to have a huge mold also to shape them and huge room or space to make them just like this in the photos. Or you can watch YouTube channel to help learning more about this wind turbine blade manufacturing. Okay, but let me tell you more about manufacturing of composite from the simplest technique. We call it wet lay up or hand lay up. In this technique, resins or later will be a matrix phase. Add into fibers. And this fiber can be in form of woven, knitted, stitch, or bond fabric. The fibers already there, resin add in, and then to wet them, the composite maker, they normally use hand roller or brush to help wet them together to make good composite, okay? Like this figures. Okay, and then if the hand layup finished, they will let this composite laminate at maybe room temperature or standard atmospheric conditions fine to let them dry and harden. And then we can have composite material, okay, of matrix or resin and fiber inside. And this is, okay, in the real job, what they do using hand roller to wet the composite. And this hand roller is actually really good help to make the resin distribute to everywhere uniformly. Everywhere the same, and also remove the air pocket or air bubble from fiber or from composite product, because it will be a defect or weak point, not good. Okay, so this hand roller to help distribute resin or matrix and then removing air bubble. That's why this technique we call it hand layup or wet layup. The easiest technique to make composite. And on the right hand side is the example of board body from hand layup technique. Okay, another technique that I'm going to introduce to this class to make composite is autoclave processing. This processing actually they are used mainly for aerospace manufacturer. And autoclave, the meaning pressure vessel. This autoclave is pressure vessel with pressure. Okay, and they use normally for the production of high quality and complex parts. Okay, and it's good for large parts and moderate production quantities, like you can see in the picture. Okay, so large vessel, right? And it can accommodate large parts also. And this autoclave, okay, to process composite. A composite material then has to be bagged and then put it in this autoclave vessel. And then this vessel will provide higher pressure. And then it will give greater compression on this composite material. Higher pressure compared to hand roller, the previous technique, okay? It will have higher pressure because of this autoclave pressure vessel, okay? With this, void elimination or air bubble to get rid of is very effective. So that's why it can provide high quality composite parts with also heating elements to help to make high performance composite part. And you can see here, autoclave operation here consume a lot of energy and also materials as well as labor intensive. So many workers has to work together and also time consuming. Actually, this technique use high energy, material, people, and time. But for intermediate production runs of aerospace industry, normally this is a usual choice, or is the most economical choice for them to produce aerospace components. Okay, and here, of course, typical application for this autoclave processing of composite materials would be aircraft, structural components, wings, tail sections, and also Formula One racing car. They're also using this technique because they want high performance composite materials. However, one thing is the size of the autoclave, okay? If the part is larger than this autoclave, it's not possible. Okay, so the size of the autoclave is also one limitation. And this is more application of composite I'm going to introduce to you. Okay, because of this composite material has very good properties and performance. That's why this fiber reinforced composite material, normally they are fiber reinforced composite, yeah? Maybe short or long fiber, you remember? It has gained popularity more and more. It's not cheap, they high cost or expensive, okay, because of the production, you can see. But still, because of the high performance of composite product, they're in need of more application, and they can find new application because of the lightweight, yet strong enough to take harsh loading condition. It's light but strong. That's why more and more application find composite material to be good choice to use as a part of products or as new material for that product or applications, especially aerospace, transportation, construction, marine goods, sporting goods, and more recently infrastructure, replacing to use more and more composite materials. In construction and transportation being the largest section of composite material being used. And many drivers to that. One of the most important is about lightweight material that are being required in transportation industry because of fuel efficiency, because of wind energy, demand more and more of cleaner or better energy, renewable energy, right? And of course, in transportation like aerospace industry. And this will be, okay, the situation before COVID-19 pandemic we're talking about. But right now, airline industry is quite struggle, but hope to recover soon enough for this situation. I hope that, as same as everyone, I guess. Okay, from composite materials, combined of materials for better performance, right? So not only composite for this material world lecture or class. We have metal, ceramic, and glass, and polymers, and then this composite materials. Yes, we use a lot of materials, and we use this whole range of material every day and surround us. So now let's talk about material dependence of us. How we are depending on materials. Let's ask ourselves. This is the important question right now, because we can see the change of the environment and the planet qualities. We heard about climate change, we heard about global warming, we heard about disaster. Many disasters happen, right? And this, I think, is a signal telling us something is wrong with the earth. And we are approaching some of Earth's resource limits already. That's why this is reaction of the action that we put on the Earth resources and limits. Okay. So let's see this graph together on the right-hand side. Okay. And we can understand more of our reliance on materials. Okay. From the graph, we can see that from long time ago, okay, we're talking about the prehistory, like 100,000 BC, long time ago. People at that time, they use only renewable material, okay? They know only wood, they know stone, they know flint, mud, okay? Natural fiber, leather, animal skin, like that. And they use only this renewable materials, okay? Things start to change 500 years ago, around 1500 AD. Okay, we start to use more of non-renewable material. You can see the change, the slope, the trend of the graph. And bad news actually came 500 years ago. Oh, sorry, 200 years ago in 1800 AD. Okay, we can see that our depending on non-renewable material is increased. That slope increased sharply. So we dig up iron ore, we making steel of it, we concrete, we create building, we use aluminum, we use metals, other metals, alloy, we dig up oil, petroleum to use to make polymers, many polymers type, okay? And then right now we use a lot of silicon-based device, like our mobile, like that. And let's see the graph from 1960 AD. I think we already 100% depending on non-renewable materials or non-renewable resource that we have. Then we use it up, we extracted this non-renewable resource, and then we use to make materials, and then assembly this material into product, and then we use it and then disposal to waste. And this is very dangerous because we change from our reliance on renewable material to non-renewable material over time. And right now, we 100% relying on non-renewable materials. Of course, it is a big problem because this non-renewable material come from non-renewable resource. And this resource, we know they cannot be replaced once they are used up because we digging it up and use it more and more. These resources, they are a limited supply to us, to this earth. Okay, so it's limit. So what we do if it's used up? And now, our environment, the change in environment telling us already that it's clear that we or our activities exceeds the earth resource threshold. It's too much for the earth already. That's why we're experiencing more disaster of the change, the global change, climate change, greenhouse gas, pollution in air, in water, in soil, in everything that we are living in right now. And from the statistical data in some location, it said that actually us, we consume material a lot. Material consumption per person per year is more than 10 tons. Because we buy car, we build house, we travel, we shopping. And that all we use up, it's from the earth resources, okay? And non-renewable resources that we extract out again, and then manufacture into materials, and then assemble into products, and then transport to use when we bind it, and then after that, dispose it or throw it away as a waste to the environment. All of this reduce the quality of the earth and this biosphere. So this is the load that everybody contributed to this one planet Earth. And if we continue our way without conscious, we don't think about it, we continue doing the same more and more. Yes, we overused the earth. We're diminishing the quality of the world and well-being of ourselves. And the greater important is well-being of the future generation. Because if this earth out of resources, this earth is not sustainable any longer. So this place will be non-survivable planet. No one can live on until that point. And the question is, do we have a spare planet to live or not? Do we have a spare planet for everyone that can move there? Or now it's just a goal for billionaire? What do we do? Unlike animals, other creatures, they have ability to make, yes, like this termite, they build tower, birds build nets. But our ability of humankind is beyond. We have extraordinary abilities through science, technology, research, and development. We can create more, much more. We have ability to make advanced material, to make better and better products to serve us, to make our life easier, right? We can copy nature. But this, our ability, our advanced technology, yes, right now, it's becoming a heavy problem to the earth. It's sad and sickened because of large-scale deforestation for development, industrial waste dumped, water pollution, large rock and soil excavation for digging, mining, carbon dioxide emission by development and transportation, air pollution. Okay. Because of this, we should be conscious now, okay, and more that, okay, this environmental load of our activity, our product and material that we use, we have impact little by little on this earth and the biosphere that we live in. How can we help to make the earth smile again, a little by little? Okay, what can we do? We can consume less, we can save energy. Okay, we can use greener energy. We can use alternative energy. We can reuse and recycle things, of course. Okay, this is what we can do. And the next question is, what more can we do? Because the more we do, the more we can do to contribute to save this one planet Earth that we have and we're living in right now, and for the future generations also. So this is the end of Material World lecture. So next time, again, you're using materials, think about this, think about environment, and you have better choice of using material and think more about sustainable materials. Okay. All right, everyone, that's all for this Material World class. Okay. Bye-bye now.